Hey guys, I'm Nicole, one of the chemistry graduate student TAs here at UT Tyler, and I've put this video together to help you run through your thermochemistry calculations for the week on Excel. Just a small note before we begin, but I'm a bit sick at the moment, so I'm very sorry in advance if my voice sounds off at all. So there are two major things you'll be calculating after you've gathered all of your data: heat of neutralization and heat of solvation. While it's great to write these calculations out by hand, at this point in the semester you guys should have a pretty good grasp on dimensional analysis and can track your units and significant figures well. Excel is a very important tool in any field that works with data management, and knowing how to work inside of an Excel spreadsheet will be an excellent skill to have as you progress in your career. Get it? Excellent? Anyway, these calculations will have a lot of moving parts, and an Excel spreadsheet can help you go through them faster while not getting lost in the sea of numbers on your usual calculator. Granted, I will be using Google Sheets for this example as I don't have access to Excel on my PC, but it works all the same. Let's begin with the actual data you'll be working with. Logger Pro will take all of the temperature measurements for you. You can export the data in .csv format, which is compatible with Excel. The data I have on this sheet is an example I wrote up for demonstration purposes, so you might have a much longer list of numbers than what you see here. The main thing you want to be looking out for in your data is the point at which the reaction actually begins, meaning when you see the temperature jump up on your Logger Pro graph. I inserted a yellow bar here in my sample data to indicate the highest temperature point after I added the acetic acid, and as you can see, every data point but one was at room temperature. From here, you can start plotting your data into graphs. Make sure as you're doing this that everything is properly labeled with the correct units. You will find the final temperature via linear extrapolation of what we call the post-reaction temperature series of data. Essentially, what this means is Excel will approximate new data points based on what it was given. This is done to account for any potential heat loss to the environment. And to do this, we need to show the equation of the line. Your y-intercept, the number at the end, is the point in which the y-axis is crossed, and this is the temperature you will use as your final for this example trial run. To find the change in temperature, you would subtract the final temperature minus the initial temperature. Now, let's move on to calculating the heat of neutralization, using the data in your lab manual as an example. So, when 100.0 milliliters of 1.000 molars hydrochloric acid is reacted with 100.0 milliliters of 1.000 molar ammonium hydroxide, the solution's temperature increases by 6.03 degrees Celsius. We are also given the specific heat of the salt solution, 4.184 joules per grams times degree C, and the density, 1.010 grams per milliliter. From this data, we are to calculate the molar enthalpy of the reaction, also known as the heat that was released or absorbed by the reaction per 1 mole of a reactant. What I would do is right away type your information into your Excel sheet. This is how I have it set up to follow my data and my units. For these calculations, we'll be using multiple properties to reach the end answer. Remember, to find molar enthalpy, we will first need to find the heat of the reaction. To find the heat of the reaction, we need to know the heat of the solution after the reaction, as heat of solution equals negative heat of reaction. And lastly, heat, or Q, is equal to mass times specific heat times change in temperature. I like to remember this equation by calling it Q equals MCAT. So we have volume, density, but not mass. Thankfully, we know that density is equal to mass divided by volume. So if we rearrange this equation, we get mass equals density times volume. First, we are finding the mass of the total solution, so we need to use the volume of the total solution. Remembering our addition-subtraction sig fig rules, we get 200.0 milliliters. Then the mass of the solution is density times volume, which is 202. Milliliters cancels out, we are left with grams as our unit, and both the density and volume have 4 sig figs, so our mass also has 4 sig figs. Now we can calculate the heat of our solution. We measured the temperature of the solution earlier, so naturally the heat of the reaction is going to be the opposite of the heat of the solution, as however much heat the reaction absorbed or let off would then be reflected in the temperature of the solution in turn. So let's plug these numbers in. Heat equals mc delta T. So the heat of our solution is 5,096 joules, we have to calculate our final molar enthalpy in kilojoules per mole, so we can use a conversion factor of 1000 to get kilojoules, since there are 1000 joules in 1 kilojoule. And then, because our delta T was 3 sig figs, our answer will then be 5.10 kilojoules. Lastly, to find our molar enthalpy, we need to know how many moles of reactant we used. Well, we have the molarity of both our starting reagents. If we pick one, say hydrochloric acid, we can then find moles using the formula for molarity, which is moles over liters. We have 100.0 milliliters of hydrochloric acid, which is equal to 0.1000 liters of hydrochloric acid. 1.000 moles over liters times 0.1000 liters equals 0.1000 moles. And then 5.10 kilojoules divided by 0.1000 moles hydrochloric acid equals 51.0 kilojoules per mole hydrochloric acid. And all those zeros are very important because they are significant. And that's how you'll calculate the heat of neutralization. From there, you'll repeat this for another 2 trials, and then you'll need to calculate the average and standard deviations. Getting these values is really easy on Excel. For the mean, simply type equals average in this bar at the top and click average. Then you can click each data point individually, adding a comma after every one, and hit enter once all are selected. For standard deviation, it's the same thing, except you type and click equals stdev with no spaces. Then select all of your data separated by commas and you're good to go. You have now calculated almost everything you need for the first half. It's basically rinse and repeat with the heat of solvation, but please pay close attention to the numbers you are required to use for your calculations. As for the theoretical heat of solvation and percent error, I will leave that to you to figure out how to include it in your Excel sheet. If you have any questions, please feel free to email me at nrichards@uttyler.patriots.edu. Otherwise, send me a message on Canvas. Good luck and have fun in this week's experiment. And I may or may not see you if you're in my lab because I am still recovering. So have a good one.